Yo. Here we go, taking a little jump into 8.1. We're going to be looking at changing degrees into radians and radians into degrees. And degrees we're definitely familiar with. This is a measurement of how we deal with angles, and so are radians. And 80 radians, you might see this on your calculator, and we'll be going through this. And so this is the conversion your calculator will be doing, and we'll be doing it by hand. Very simple. So if you're given a degree, you're simply going to multiply times pi over 180. And if you have a radian, you're going to be multiplying times 180 over pi. So think of radians are going to have pi in them. That's why we need it at the top. And degrees are not going to have pi in them. So that's why it's on the bottom. So it'll cancel out. You'll see that. Also, in your computer, when you type in a pi, you can just type in the letters P-I to spell out pi. And that'll give you that symbol. Or you can use the symbol at the bottom in the legend. So here we're given degrees. I'm going to put that degree over 1. And I can multiply times pi over 180 and then simplify. Very simple stuff going on here, people. Then we're going to take a look at complementary and supplementary angles. If you can't remember, complementary is when we have two angles whose sum is 90 degrees, and a supplementary is where two angles sum is 180. So we simply subtract from 90 for the complement, and we subtract from 180 for the supplement. Same here. Here we're going to be doing that very same thing, except we're going to be doing it in radians. And so I've converted 90 degrees is pi over 2, and 180 degrees is simply pi. And just like above, we subtracted from 90 to get it. We're going to have to subtract from pi over 2. We have to get common denominator, and there we go. Here we're going to be subtracting from 180 or pi, get common denominator, bingo bango. A complete rotation is 360 degrees. The given degrees are 120, reduced to 1/3. Here, this is a straight angle, which is equal to 180 degrees. So we set up this equation, solve, plug back in for our solutions. Here, this little symbol here represents a right angle, or 90 degrees. So when we add these two up, it should equal 90 degrees. Follow through, plug back in. Here, a little reminder here of where our quadrants are. Quadrant 1 is here, and we're moving in a counterclockwise rotation. So quadrant 1, quadrant 2, 3, and 4. And just a reminder that our x and y values are both positive, negative and positive, and so on. And we're going to be looking at what's called the standard position. So this is where we are starting at the x-axis between quadrant 1 and quadrant 4. So this is where we're starting here. And then we're moving in a counterclockwise. So we're going in a counterclockwise rotation. So for 50 degrees, I simply start here, I move up 50 degrees, and I'm done. Now when we start looking at least positive coterminal. So coterminal is simply the same position. So where 50 degrees is, we're like, all right, we want to do that same thing. So as we can see here in this green one, it is a full counterclockwise rotation. So we're going to be adding 360. So you see the swirl. We're starting here, going all the way around. So that is 360. We're back at our starting point, and then we go 50 degrees. So 410 degrees represents the same location as 50 degrees. And then when we do the greatest negative coterminal, we're going to be subtracting 360, or a full clockwise rotation in the negative direction. Sometimes, it depends. And so here, we start here, we're going in this direction. So negative isn't really about a value, it's more about direction. Going in a counterclockwise means a positive direction. Going clockwise represents a negative rotation. So here, we're going in a negative rotation, negative 310 degrees, and we stop here, which is the same location as 50. So 50, 410, and negative 310 have the same coterminal. And we're doing that same thing here. 116 degrees, we're starting here, rotating counterclockwise. And as you can see, as we do one full rotation, we're adding 360 for our least positive. We end up in that same location. And here for our greatest negative, we're going in clockwise in that negative direction for negative 244. Adding 360, adding 360. Here we are converting from degrees Here, make sure we always keep that negative. It doesn't fall off, all right? So whenever we're converting, that doesn't mean it becomes positive or it becomes negative. Here we're converting radians to degrees, multiplying by 180 over pi, and reducing. Here we're going to be doing the same thing, except we're going to be putting it into our calculator. And so 58 over 1, multiply. You don't need to reduce here because we're putting it into our calculator. And if you need to find the pi button on your calculator, it is the button above the division sign. It's got a little caret. So if you hit second and that button, you can see a little pi symbol up above that. Then now we're dealing with arc length. This is S is equal to R times theta. So this symbol is a Greek symbol for theta. And this is a measurement of angles. And these are only in radians. All right, so arc length is S, radius is R. And so we are given our theta, or our angle measurement, is already in radians, so we don't have to do anything there. We're given our radius, so we simply have to multiply. Here we're given our arc length is 20. We're given our theta, which is already in radians, and we're looking for our radius, so we need to multiply each side by its reciprocal. Here, we're using our calculator here, so we're given our radius, and we're given our radians and theta. Make sure you round. And then here, once again, we have to change our given 45 degrees. We have to change that to radians. As we see, we get pi over 4. That's what we're going to be using in our equation for theta. We're given our radius. Put that into your calculator and round correctly. Then we're looking at the area of a sector, which is pi r squared. R squared theta divided by 2 multiplied by 1/2. Either way. So we're given both things. We don't have to convert it. Oh, we do have to convert 72 degrees. You can choose to simplify this if you want, or you can just use 72 pi over 180 here if you want. Doesn't really matter because we're putting it into our calculator. And in our last one, we have to figure out here what our theta is. We are given arc length S, and we're given our radius. And so we figure that our theta is here, and that is the theta that we use here in our area equation.